Autonomous data. Let me explain that with a little bit more clarity. The question that came in was someone who was new to autonomous. They said, all the stuff I've seen in the autonomous talks, of which I've done some as well, they talk about everything being autonomous, which would make sense. That's what our offering is. And this person said, don't get me wrong, I like the ease of creation and patching, etc. And so do I. One of the things I love is click, click, click. There's my autonomous database, as opposed to write some scripts, fire up DBCA, etc. And then someone said, but with the exception of automatic indexes, isn't it really just another database? And that's probably a fair comment, because if you look at the literature that's out around autonomous, we say, self-tuning, self-healing, self-patching, etc. And certainly the infrastructural side of things, I think we can claim to be autonomous from the perspective of the customer, i.e., you don't have to worry about backups, you don't have to worry about patching, you don't have to worry about all that infrastructural stuff. Certainly provisioning, etc., is just literally trivial. That's one of the things I love about it. But there's an argument to be made there that that's what any cloud database should be like. So what makes it the next leap to be autonomous? And automatic indexing is certainly one of those things, but is that the only thing? I think it's safe to say that we're on a journey here. Automatic indexing was probably the first thing out of the box in terms of adding more autonomy to the autonomous database. There are things going on behind the scenes. We use some of our machine learning algorithms to trawl through logs such that if customer X starts seeing some problems, that information can be used to fix up customer Y and Z in advance. So there are things behind the scenes that also have some autonomy about them, but customers generally don't see that. So in terms of being on a journey, we're not trying to hide anything from you. This is actually in a roadmap. You can go to the documentation it has. These are the automatic operations that are either there or coming. This, I think, was taken from the 21C features. So these are all the things that are actually, I think, are already in there in most of your autonomous offerings, depending on what region you're in. Automatic indexing, you've seen. But automatic index optimization is coming, which is we might choose, for example, what level of compression to have on those indexes that we automatically created, or even your own. One of the things that people use so infrequently, and you can, there's advanced index compression, which is a licensed feature, but basic index compression, key compression, has been there since 8i, yet so few people use it. So that are the kind of things that we're going to maybe take on that responsibility for you. Automatic materialized views, automatic SQL tuning sets, temporary table space shrink. You do a monster sort and your table space goes out to there, and next thing you know, you get this giant file chewing up space on your file system. We're going to have a facility which will shrink that down over time. That's not such a big deal for existing DBAs, because nowadays, if that happened, you'd simply drop one temporary table space, create a new one, and off you go. This one's a bit bigger though. Automatic undo table space shrink. You do a monster transaction, it gets this big, and then the contraction's committed. Well, you've got undo segments out here at the very end of the data file now. That can be a problem because you can no longer shrink those data files. We're going to add that into autonomous as well. Automatic zone max, object activity tracking system, sequence dynamic cache resizing. I spoke about that in a recent office hours, and also I did a blog post about this. I said, we've killed sequence contention. Even if you choose a tiny cache size now, we will dynamically adjust it as you're running your system. You could argue maybe that's not autonomous because you can get that available on premises as well. One of the things that's not listed in that list is something that actually is floating around autonomous today, which is automatic partitioning. I've got a big table, I query it regularly. Maybe there's a better option in terms of carving that data up into partitions. This is fairly new, and I think at the moment we only activate it in reporting mode as opposed to implementation mode, so it simply reports on what's possible. But on your behalf, I created a autonomous data warehouse, loaded up a big chunk of data, ran the automatic partitioning thing, and actually I just thought I'd show you some of the output to give you a hint as to some of the more autonomous stuff that is coming very, very soon. So let's create a table called A part. It's going to be for automatic partitioning. Big shout out to Nigel Bayless, the Optimizer product manager. He helped me with a lot of the scripts on this demo. I'm going to insert, what have I got there? 150 million rows. And if we look back at the table, I put this padding column in there, 1,000 bytes. So it's a big table. And you can see it took a couple hours to load. I'm literally doing this on the very bare bones single CPU autonomous offering you get, but it's a 100 gig table. Has to be a big table because otherwise, why would you bother partitioning it? If I look at it, It says, I'm going to run some queries now because this is let's say a data warehouse table. I'm doing a lot of date range style queries. So here's some stuff for March. Here's some stuff for just one day in March. Here's some stuff between January 1st and January 5th, etc., etc., etc. I think I ran 10 different queries on this table. I didn't put timings in, perhaps I should have, but one of the things that blew me away was these were still remarkably quick because of the value of things like Exadata storage indexes. The first scan took a long time, but the rest of them actually were remarkably timely, even on my little single CPU autonomous database, because storage indexes kick in and also smart scan on storage cells, etc. All the goodies of normal Exadata came into play here. But I did all this. I said, okay, I've done a lot of queries here which are date-based. Is that enough to tell the database that maybe some partitioning is useful for this particular table? And this is the process as to what's going to happen. The database is probably going to do this a lot by itself, but I thought I'd walk it through manually for you to see what's actually going on in terms of the concept of automatic partitioning. I'm going to create a SQL set called my SQL set, and I'm saying, go get everything that my particular user, the admin user, had run in this particular database up until now. That's going to pick up those queries against my A-part table, but also everything else, obviously. So the next thing I do is I'll delete from that tuning set anything which is not select sum from A part. Therefore, I'm just isolating now the 10 queries I ran that are typical warehouse style queries with a date range, etc. If I go look at my SQL set statement now, I can see I've captured the 10 typical queries that I ran. One for a single date, the others are for betweens, etc. The first thing I do to see if a table could be automatically partitioned or autonomously partitioned is I got this thing called DBMS auto partition validate candidate table. I pass in my A part table, I pass in my SQL statements that have been run against it, and it says, yep, there's a good chance that this would be a candidate for partitioning. There might be reasons why it not be, depending on the way the table is structured. For example, if it had particular data types, that means it couldn't be partitioned, etc. So the various checks that would normally undergo here that you would do manually are done by this particular facility. Now, I'm going to set partitioning mode here to report only. So I'm not going to actually implement any changes. I'm just going to ask the database to go ahead, just like we can do with automatic indexing, to actually go through the entire process of deciding on automatically partitioning this table, but not finally doing it. And this is how it works. I'll come to this cursor shortly. The first thing I do is I say, okay, I've got R being a raw. It returns me a GUID. I want to recommend a partitioning method based on these SQL statements based on this table. I'm just going to ask for a text report. And then once the report is finished, let me pop back to that cursor. I'm going to query my automatic partitioning recommendations for that particular key, that GUID that came back. And it ran, it came and it said, yes, this is what I think you should do. That table in which you did a lot of date range queries, I think we should partition it. We should partition it by list. At which point you're going, what? When would we ever partition date range things by list? Please bear with me, I'll explain. So I'm doing a list, sysop interval high bound. I'm doing a 1 month interval. That's my starting partition, and the partitioning key is the column called D. Now, why would it choose list partitioning for a date range? One of the problems in this table here is I never nominated that date was not null. As a result, I could put nulls in there. And as you know, you can't put nulls in interval partitions because they're not designed that way. So if I want to get the benefits of interval partitioning and this column can still allow nulls, I've got a bit of a conflict. To solve this issue, in Autonomous Database, we've actually built a new kind of partitioning method. It's a list format, but we put an expression around here to make sure that we never ever end up with nulls. It's actually a list partition on a function-based index, effectively, or function-based expression on the partitioning key. That has some smarts in the optimizer layer to know that even though you just do normal date range queries, if this table was indeed partitioned in this fashion, it will be able to work out how to do partition elimination. So that's why we had to use lists. We had to actually invent an interval partitioning mechanism that would cope with nullable columns. That took 3 hours to run. And that's why it's just like automatic indexing. If you've seen some of the automatic indexing slides, we don't just go, does a theoretical explain plan suggest this might be better? We actually go build indexes, test run queries, and make sure they're better. That's what's going on in automatic partitioning. we will actually build a copy of your table in a partition form and then test run those queries against that new partition table. That's obviously an expensive operation to copy your table into a partitioned equivalent. This ran for 3 hours. Once again, just single CPU. In a real autonomous database, you'd obviously be cranking it. But on a single CPU, it's going to run for a long time because we don't like being iffy. We don't like being vague. We are going to guarantee that we can quantify the benefits, if any, of moving this table to partitioning. That's one of the cool things. We're cautious. Same with automatic indexing. Lots of caution to make sure that we guarantee the results we're getting. And then out comes the report. And the report is comprehensive. If there's one thing I can say, it's ridiculously comprehensive. It starts off with we ran it as a system task. It has some bits and pieces there. That's the key name, the GUID that came out. It goes through all the bits and pieces. It talks about what the impact is. Things have to be, if a SQL is impacting more than 1% of the overall load, then that's a candidate, etc., etc. But then it comes up with a sort of a summary. It says, I reckon that if we partition this table, we'll have an improvement of 91% on the response time of those SQL statements that we considered, those 10 SQL statements. And it tells you there was 10 there that we looked at. And then it lists them. There's the SQL IDs. It says, here's the improvement. I had 92% improvement. These are all fairly predictable because I went from a year of data and all these queries ended up scanning a 1 month. Therefore, 1/12 of the data, so about 8% of the data needs to be scanned, therefore a 92% improvement. And then for each of those SQLs, it says, here's your SQL ID, here's the SQL statement, here's all the bits and pieces on before and after. You can see we test ran them on the old table, and then we test ran them on the new table to see what the benefits are. And we have elapsed time, pass time, and we get that for every single SQL statement, including we get the execution plan before the table was partitioned, or its version would be. So yep, that's what the query looks like before, just a normal Exadata Smart Scan. And then afterwards, against our template table, it would be partition list single. And therefore, that's the benefit we saw. And you get that, the stats, the before plan, after plan for every single SQL statement, and we're done. The reason I made my table so big is because we have a 64 gigabyte entry point. That is configurable, but that's what we recommend. Anything less than 64 gigabytes probably isn't worth partitioning on an Exadata system because the speed at which we consume data on Exadata is just insane. And therefore, I think we're up to about 20 gigabytes per second now. So really, you have to have a big table to make it worthwhile. I suppose the key thing is the reason we're being very cautious with automatic partitioning in terms of not just turning it on for everyone silently on autonomous is there's an important cost versus benefit sort of relationship here. As you saw, the time it took me to evaluate the benefit of partitioning a 100 gig table was 3 hours on this system. Now, as I said, single CPU system, but even on a big system, we're going to copy that table. So if you get a 10 terabyte table, we're going to have another 10 terabytes copied there, and then we're going to smash away at it with lots of sample queries to make sure this thing is guaranteed to give you a big benefit before we actually would flick the switch. Just like automatic indexes, caution, 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 because we never want to have a regression. We only want to have a positive result. So be aware that that's the reason we're cautious on this is there's a cost versus benefit here. You want to get big benefits, but we're going to burn a lot of resources here to make sure those benefits are realized. More enhancements are coming. You'll see more and more things that have the word automatic in them in the autonomous offerings because we are heading toward that genuine utopian goal of a database that literally makes decisions on its own right to make life better for you as developers and as DBAs.